Okay, so today I would like to discuss Snell's law. So, Snell's law is about how light behaves when it travels between two media, let's say air and glass, or any two media, where in the first medium the velocity of light is v1, and in the second medium the velocity is v2. So, as we shall see, light changes its direction, and it changes its direction as follows. The rule is that the directions are such that sine theta 1 over v1 is sine theta 2 over v2. So there is a deflection. And the reason, as we shall see, is that in this way, light travels at the minimum time between the points, the initial points A and the final point B. So that goes under a principle which is called minimum action. And in this particular case, the minimum action is the minimum total time. Let's see why. Let's consider an analogy. Suppose that we have a lifeguard at a point A. And there is a person in the water at a point B, and the person is drowning. So this is the sea, this is the shore, and the lifeguard wants to reach the person at the minimum time. Now, the velocity of the lifeguard at the shore while it's running on sand is v1, and the velocity of the lifeguard while it's swimming is slower, it is v2. So the lifeguard has to find the best point to break. So it doesn't make sense that he will do something like that, like choose this path or even the shortest path. It wants to run some time and to swim some time. Obviously, to swim less time than run because he runs faster. V1 is, let's say, V1 is larger than V2. So there will be a point where it will break. And the question is, what is this point? As we shall see in a moment, the point is such that we obtain Snell's law. Sine theta 1 over v1 is sine theta 2 over v2. Let's see why. So let's parameterize the problem as follows. So again, this is the point A, this is the point B, and let's consider the distance, this distance, let's call it y. This is x1, this is x2, and let's divide y into two segments, y1 and y2. So the total time will be, well, this distance is square root x1 squared plus y1 squared. This distance is square root of x2 squared plus y2 squared. So the total time is t1 plus t2. This is square root of x1 squared plus y1 squared over v1 plus square root of x2 squared plus y2 squared over v2. Now, we can substitute, we can use y1 plus y2 equals y, namely y2 is y minus y1, and therefore the total time, capital T, can be written as square root of x1 squared plus y1 squared over v1 plus square root of x2 squared plus y minus y1 squared over v2. And let's see how we obtain Snell's law. So t is the total time, and let's consider the derivative of the total time with respect to y1 and equate it to 0, because we want to check what is the right point y1 to break between the shore and the sea. So we vary with respect to y1 and find the minimum by taking the first derivative and compare to 0 and equate to 0. That gives 1 over v1 y1 over square root of x1 squared plus y1 squared minus 1 over v2 y minus y1 over square root of x2 squared plus y minus y1 squared, and that's equals 0. So what we have is 1 over v1 y1 over square root of x1 squared plus y1 squared minus 1 over v2 y2, because y minus y1 is y2, over square root of x2 squared plus y2 squared equals 0. So this is 1 over v1 sine theta 1 minus 1 over v2 sine theta 2 equals 0. And this is Snell's law. So what we found is that when a person wants to travel between the point A and the point B in a minimum time, and that person, the lifeguard, has velocities v1 and v2, the best path is according to Snell's law. And light does the same thing, which is amazing because what it means is that light travels between the initial point A and the final point B at a minimum time. How does it know? That's a very interesting question that I will not answer.